Hello everyone. So we are continuing with our design pattern series, and in this video we'll cover bridge design pattern. So let's get started. So we'll start with what is bridge design pattern, why we use it, how to achieve it, and then code implementation in C++, and finally benefits and disadvantages. So bridge design pattern is a structural design pattern. So far we have covered all the creational design patterns. Now we are starting with the structural design pattern, and this is one of the easiest structural design pattern. Okay, so bridge design pattern enables splitting a large class into separate hierarchies using abstraction and implementation. Now all of these are heavy words, but we will understand what it means, right? And it scales well with more features if you add in the future. So we will also understand how it does that. So let's start. Why use bridge design pattern? So consider a scenario where you have a shape class. It's an abstract class you can consider, and you want to create different type of shapes. So you create a circle class which extend this shape class, and it has a property of a circle. Similarly, you create square class, and so on. You can create other classes as well. Now let's say a requirement came up where you have to add a new property to this shape, which is color. And at this point you have to add blue and red color to the shape. So the simple way is to create separate classes with each property. So you can create a blue circle, blue square, red circle, and red square. Now we can see that there is an issue in this approach. Let's say if you want to add a new color, green, in future, so you have to add two more classes for each shape, right? And if you want to add a new shape, for example, if you want to add rectangle maybe, then you have to create two classes with each color. And as color and shapes will increase, your number of classes will also exponentially increase, and it's only two properties. Now let's say if you want to add a third property to a shape, then you can see it will scale exponentially as you add a new property. Now how does bridge pattern solves this? So let's see how to achieve this. Now in the bridge pattern, we extract out each property into a separate class. So rather than creating a big class containing all the properties or all the combination of all the properties, we create each separate class for different property. For example, we extract out the color class as a different property and consider it as an abstract class, so that whenever you add a new color, you can create a separate class for that, and the shape, your original class, will contain the color rather than, so it will contain the object of this color class, appropriate object, if it's a red color or a blue color. So you can see this is a aggregation relationship arrow, so which represents that this class is contained in this shape class, and it can also exist independently from the shape class. So shape class will have a variable or object of color, and it will have its own functions as well. So similarly, now you don't have to create a separate red circle or a blue circle. You can just create a circle and a square, and the circle will contain this color object of appropriate type, either red or blue. So now you can see if you want to add a new color, then you just have to create one class for that. Similarly, if you want to add more shapes, you just have to create a one class for that. And similarly, you can imagine if you want to add more and more properties, you will have a different classes, and those objects will be contained by your main class. So this will help you scale as well. You can linearly scale. So this is where abstraction and implementation came in, that you abstract out all the properties, and you will have the concrete implementations of those properties, and they will also be separately or independent with each other, so that they can also scale well. So that's it. This is a very simple design pattern, and we probably use it already. It's just that we have just put it formally that this is a bridge design pattern. So now let's quickly see the code which we have just discussed. So as you can see here, let me just go to the code. So as you can see, first let's create a color class. So this is an abstract class, and this color method will be extended by its children classes, right, or subclasses. So red class we have created, and it will print that it's a color red. It's a very simple code. You can imagine that we can have more functions, and we can have more sophisticated functions as well. Similarly, we have a blue class which says it's a blue color. Now in the shape, we will have a private variable of type color which will store the appropriate color type, and during the creation of this shape class, we will pass this color object in the constructor. Right, so whenever you want to print the color of this shape, you will just call the color of this color class. And similarly, let's say this has one more shape function which needs to be implemented by its subclasses. So we have a circle class, and here let's say it prints that when you call the shape, it says it's a circle with color, whatever the color it is. Right, and this color function we are calling here. So it's like in the shape it is already defined, and it is calling the color of the color class. Similarly, the square. So now in the main class, what do we do? Whenever we want to create a new circle, we pass all the objects of its properties. So it has a red color property, so we create a new red class and pass it in the circle. So when you print the shape, it will print appropriate value. So we can quickly see as well. So it is printing circle with color red. Similarly, you create a square with color blue, so it is printing square with color blue. Again, very simple code, and all of these codes are available on my GitHub. I will link that down in the description also in this video. So that's it with the code. Now let's come finally to the benefits. So we can clearly see the benefit of this, right? It first of all create platform independent classes and apps. So whatever feature or any extension you want to add to your system, you just create a separate hierarchy, separate classes for that, and use those classes in the existing classes. And it enables to explain classes in different dimensions independently. This is what we just mentioned. And it also enables switching between different implementations at runtime. Now consider a scenario where you have a service which uses different database servers. So what you can do, instead of creating different classes with each database which uses different database servers, you create only one class and have a database server object with it using a common interface. So now you can pass in any database server object, and accordingly it will call that server. And you can also switch this runtime. So you can have a set function, that set server, and that will also help you change the server connection at runtime. So instead of so what it help you, if you have seen in the code, when we are adding the color property in the shape, we can also modify the color. We can have a different function that modify colors. It will pass a different color, and we can update our shape class. So that's also help in the runtime updation of the different implementations. So these are all the benefits. And disadvantage, as usual, it adds an additional layer of abstraction which might increase your system complexity, but overall it is very useful in scenarios which we have mentioned above. If you have different properties, or if you want to switch between different implementations at runtime. So I hope this helps you understand the bridge design pattern. I just want to keep this video short because it's a small design pattern, and I want everyone to understand it quickly. So yeah, that's it about this video. If you have any doubts, please let me know in the comments below. If you like this video, you can hit the like button, and I will keep making more design pattern videos, so stay tuned. That's it for this video. Bye everyone.